So next up is Kaustubh GANDHI, who's a senior product manager for software and solutions at Bosch Sensortec, where he leads highly innovative work in advanced signal processing, supervised ML, and self-learning AI sensors. Please take it away.
Thank you. So welcome everyone. Good morning. My name is Kaustubh GANDHI. I'm product manager at Bosch Sensortec. Today we'll be mainly talking about insights for edge AI systems from our latest self-learning AI sensor. And be happy to receive your comments, questions, and so on towards the end of the presentation. So let's get started. So we started this journey with a question that is there a shortcut to a healthy urban life, which is often busy, expensive, distracted with gadgets, and where there is very limited time for fitness. And what we realized is that there are, in fact, like all things come in three, there are, in fact, three good ways of improving fitness even in urban lives. One is to gamify your activities related to fitness to improve the motivation for continuously doing it and trying out new things, to get good real-time feedback on what you're doing, and then also looking for incremental challenges on what is next that is coming up, and then do activities in high intensity so that they are packed together in order to maximize the amount of the fitness improvements in a very limited time. So with this, we came out with world's first self-learning AI sensor targeted towards wearables and hearables, with a unique self-learning AI software, which is what we'll be talking about today. This sensor is also packaged with several pieces of software, including swimming analytics, position tracking, orientation tracking, and could also be programmed as an openly programmable system for further applications, which can make use of the sensor components itself, that is accelerometer and gyroscope, and also including other virtual sensors with self-learning AI software and orientation and so on. So let's go straight into the insights. The first one is that we saw that from the fitness tracking, there is a wide variety of demographics which need to be supported. And also for individuals, the energy levels are very different when they start the fitness and during doing the fitness and towards the end. And also there is a very high expectation of novelty. That is, people expect that the devices perform something new. They bring new activities on board, or they are able to use the device for multiple purposes. And with that in mind, we introduced learning functionality inside the sensor itself. So with this learning functionality, what we saw is that users are not only able to personalize the device for their particular style of usage and customize them for their use, as well as the users are able to learn new activities and make use of the same device for more purposes over the lifetime. So especially as their interests change and as they see that they would like to try new things and so on, this is something that helps them to personalize as well as make use of the device for multiple purposes. So here, the self-learning AI technology basically deduces new time series patterns from end users directly in less than 30 seconds. This could also be done by manufacturers and so on. It helps to personalize the device to end user style. And then it starts automatically tracking these existing and the newly learned activities. So when the user opens up the box, they get already something that is pre-trained inside the device, and plus whatever comes in new over updates and from the end users and so on, all of this can be tracked automatically without any change to the sensor or to the software and so on. This helps in users to get engaged with real-time feedback, with classification, counting, and so on. And all of this happens inside the sensor itself. So So definitely all the data coming from the users has the potential to stay 100% private to the users. So the insight here is that learning on the edge is really key to personalization and personalization of the device in real time. The second insight is more from a designer's view. So as users of AI systems, we all know how difficult it is to understand what is exactly happening inside the device, especially when it has learned new things or when it is working or not working on using the AI capabilities. And that's where we bring up designer tools, which basically show that what is the time series data that is coming in, where in this time series data has the system learned a new pattern while it is learning, and also where is it that it is correlating the best during this time. So as you can see here, in for example 30-second data, you can see that after few repetitions a new pattern was learned. It also shows what does the pattern look like from sensors such as accelerometer and gyroscope, and then also shows where is the matching happening, so that if the designers feel that no, I would want some other pattern to be recognized, they could reconfigure the system as if it in real time, and then regenerate the patterns right away for usage in multiple product segments. The third insight comes again from the designer's perspective, but more from labeling point of view. So, labeling is never perfect, and at the same time, it always has to be done meticulously with exact start and stop of events, especially when there are transitions and so on. And that's where we feel that the edge AI systems of our age should actually support even poorly labeled data. So as you can see here, since the software itself is self-learning, it automatically identifies what is a relevant data out of this and what is a junk data, and actually discards the junk, whether it is coming in the beginning or in the middle or in the end. The next insight for edge AI systems is more about scalability. Since we want to have a platform or a solution which can actually be used for more than one usages, especially in order to enable scalable systems or design of scalable systems. And that's where we see that supporting different sensor combinations, for example, whether it is accelerometer, gyroscope, magnetometer, or pressure, and also enabling virtual sensors together with the physical sensors is something that is needed for edge AI systems. The next is about user experience. So while we talked about the technology itself and about the designer's view, it is also important to understand that in the edge AI systems, it is we have to consider how does the user really expect the AI to behave. And while personalization is great, it is difficult for a user to actually inform what is a good time for personalization and what is not a good time for personalization. And that's where automatic personalization in the background and tracking of activities when they are switching, when they are happening in real time, this comes into picture. So what we see here is our typical results from 15 different activities that we support as built-in activities inside the sensor. And the numbers represent F1 scores, 0 to 1, 1 being highest accuracy, and so on. And you can see that there are activities which work very well only when they are personalized to the user. And they do not work that well when they are happening on a very general level. And then there are some users which are really good as standard users. And then there are some users which require personalization, and some which require a lot of personalization in order to really have a good user experience. And this is where automatic tracking and seamless personalization comes into picture when you want to build an edge AI system which is personalized and which is also useful for tracking something in real time. The next insight comes from our swimming analytics software, which is also packaged together with sensors. This software offers counting of laps, classification of styles, and also counting of strokes while the user is swimming. And as you can see here, the goals of the user are basically to get information about scores of swimming, such as wolf, getting information about speed, distance, and efficiency, and so on. And this means that one single piece of AI software will not be able to solve something like this. So while designing the hardware over here, we have to consider the fact that that there will be AI components, for example, for classification, regression, estimation, and so on. And then there would be also non-AI components, which actually do a lot of custom signal processing. And what this means is that edge AI systems need to have both AI components and also support for lots of custom signal processing. The next insight is more from position tracking, and we have seen those cases where GPS or GNSS systems are basically not always accurate, or they even consume a lot of power while moving and so on. And what we need here is basically a holistic design for a good balance between accuracy and power. So if you use, of course, GNSS only systems, then you end up with getting the best accuracy, but then spend a lot of power, and often it is difficult. And then if you go with duty cycling of GNSS, you can save power, but accuracy is not that great. So what we offer is a combination of pedestrian red reckoning, which is generated from inertial sensors and fused together with GNSS, so that we have a good balance of accuracy and power. And what this means is that we talk not only about the power consumption of individual components, but basically looking at the power consumption of the system itself. So here's a quick summary of all the insights that we had. So basically, learning on the edge is key to personalization. There is also automatic visualization of the system's learning needed. An edge AI system cannot go without supporting for poorly labeled data, especially with data that is coming from time series and is coming from multiple sensors and so on. We need to support scalability for the software and the hardware across product segments, and cannot be designed only for single products. We have to track automatically among the activities which the users are doing, while enabling personalization seamlessly in the background. The edge AI systems need to have AI, but also lots of custom signal processing, which may come from non-AI components. And finally, even though power is very, very important, a holistic design for accuracy and system power is really important to give a good user experience. So that's a short summary of my talk. Please feel free to ask any questions or comments on this topic. And I would like to also thank tinyML community for offering this opportunity to share these insights, and looking forward for more such discussions. Thank you.
Thank you very much, Kaustubh. This was a very good example of where tinyML technology can really make a difference. Very small footprint, low power. One of the questions we had from the audience is, the analysis that you're doing to figure out if it's a new pattern, do you use signal processing in correlating the X, Y, and Z, let's say, dimensions, or do you use another way of aggregating, for example, comparing features in an embedded space? Yeah, which of those?
Right. So this is a proprietary patented technology from Bosch, which is using real-time time series data and definitely taking into consideration all of the physical sensors available inside the sensor. And it can also be coupled together with virtual sensors, which are also inside the sensor. So in short, the patterns that are generated in real time, this takes into consideration everything that is available, which the sensor can access, and then generate a pattern that represents, that is more or less a fingerprint of the overall activity.
Okay, and what question is, do you actually modify the models, or do you keep the models the same and it's the comparison point that changes? Or do you do it on device actual neural network learning?
Right. So the patterns themselves are modified while when the option of personalization is selected. So we give a configurable system to the users or to the manufacturers, saying that you can enable or disable the personalization depending upon when the performance is good or bad, or depending upon your personal choices. And the option for replacing the patterns as they are learned or personalized, this is open to manufacturers or to system designers.
Okay. Okay, thank you very much, Kaustubh.
Again, just a quick shout out to our sponsors. Bear with me for 1 minute. We have different categories. We have executive sponsors. First one being ARM. Then we have Qualcomm. We have Samsung. Platinum sponsors. Ada Compute. Lattice Semiconductor. Gold sponsors. BrainChip. Babel Labs. DSP Group. Edge Impulse. EMSA. Gray Matter Labs. Greenwaves. Himax. Imagimob. Latent AI. Maxim Integrated. Quixo. Reality AI. tinyML. Silicon Labs. Sentient. Google TensorFlow. XMOS. And lastly, silver sponsors, Edge Cortex, Hotchi, and Synsense.